let's do question 1, please. Is anybody else coming? Don't know. We'll start working on question 1. Both questions are on the Neiman Pearson llama, and you may remember we did this in the last lecture before the Easter thing. I know it's been a while, but I hope you guys remember the Neiman Pearson llama. I think I did one example on it before the Easter break. So just to show you, just maybe I would just do question 1, and hopefully you can do question 2 by yourself, okay? Because I think I had done only one example, like the question before, so maybe you're not really familiar with this. All right. So you have in question 1 you have three 3 observations from a Poisson distribution with parameter lambda, and we want to test, or we want to find the most powerful. Remember the term that most powerful means any test obtained using the NP lemma is a most powerful test. So when the question says find the most powerful test, it's implying that you must use the Newman-Pearson lemma to find the test, right? So by the Newman-Pearson lemma, we reject H0 if you look at the last page of the lecture notes, you will see the rule for rejecting is like this. It's the ratio of the likelihood in the top is the likelihood at the null hypothesis divided by the likelihood under the alternative hypothesis less than a constant c, right? So in this case, this will become the likelihood at 1 is simply the product from I from 1 to 3 of E of minus lambda, which is 1 to the power xi divided by xi factorial, right? This is the likelihood at lambda equal to 1, and the likelihood at lambda equal to 2 is E of minus 2 power xi divided by xi factorial less than a constant c. Yeah, you see I got this right. Now next, you just need to simplify this. You can see that this will cancel with this, and 1 to the power anything is 1. Okay, so this is equal to 1. Okay, so what you have is in the top you have E of minus 3, right? Okay, it's multiplying this 3 times. In the bottom you have E of minus 6 to less than a constant c. Okay. Simplifying this further, you get this. Right, now I'm going to take this to the right hand side. Yeah, you will get in the next step, I'm going to take the logs. I'm going to take the log of the left and the right hand side, so it becomes this. And finally, I'm going to divide both sides by minus log of 2. Remember, when you divide an inequality by a minus number, you need to change the sign of the inequality, right? So when I divide by minus log of 2, which is a negative number, the less than will become greater than, right? Okay, so this, what I have written here, is the rule for rejecting the null hypothesis under the Newman-Pearson lemma, right? Now, for the sake of simplicity, I'm going to call this, instead of writing this every time, I'm going to just call it some other name. Let's call this K, right? So the rule for rejecting the hypothesis is that x1 plus the sum of the three observations is greater than a constant K. Now the next step of the question, what the question is asking you, is to how to determine how to determine the value for k, right? And this is why we need to use the value for alpha that is given in the question. If you look at it, guys, you'll see that the question gives you a value for alpha. Remember what alpha is? We did alpha is it says that alpha is 0.1, which means, remember from before the break, alpha used to denote denote the probability of type 1 error, right? Which is the probability that you reject the null hypothesis, right? You reject H0 when H0 is true, which is lambda equal to 1, equal to 0.1, right? So this is the probability that under the Neyman-Pearson lemma, we just saw that rejecting H0 amounts to this, right? Given that lambda equal to 1 is 0.1. Now, I don't know whether you know this, that if you have independent Poisson random variables, then the sum is also a Poisson variable. It's a known fact, right? So here, each of these is an independent Poisson variable with parameter lambda. And therefore, by using that fact, the sum is also a Poisson variable with the parameter of the Poisson will be the sum of the parameters of the 3. So it will be 3 lambda. Yeah? So it's just simply the sum of the parameters of the 3 variables. Greater than k equal to lambda is this, right? Now, if you put, let me take this away. If you put lambda equal to 1 into this, you get the probability that a Poisson variable with parameter 3 is greater than k is equal to 0.1. Now, this equation, you need to solve this equation for k. So the only thing that is unknown in this equation is the value of k, right? But unfortunately, there's no, you cannot solve this equation analytically. So it must be, this must be solved numerically using so this equation here must be solved numerically using some computer software like R, for example. I know some of you know R, right? Yeah. So you can use R, for example, to solve this for k. Now, once you know what k is, then you have a proper test, right? So the conclusion is the following. The conclusion is by NP lemma, we reject H0 with alpha equal to 0.1 if x1 plus x2 plus x3 is greater than a constant k, where k satisfies, I'm going to call this equation star, okay, where k satisfies this. So this is the conclusion to question 1. Right. Okay. I mean, this is a typical question. You will get a question on Neyman-Pearson lemma in the final exam on the 23rd of May. So it's a typical question on. It will be like this, right? So if you understand this, okay, can you do question 2, please? Question 2. super. You okay? So,
yes. So that's fine. I think that's right. I'm just doing what to do now. So
try to simplify the right and left hand side.
okay.
Yeah.
I'm showing. So can I cancel these two bits out? So
No, can't. If it is composite, then we can show you, like, for example, if theta equal to, suppose theta equal to theta 0 versus theta not equal to theta 0. In that case, we can just assume that theta is equal to theta 0 and versus theta equal to theta 1. Theta 1 is not equal to theta 0. Okay.
I would be why I would try it. So
you could do it like simple hypothesis. You could do it like simple
no, I don't think we are.
and treat it as a simple hypothesis.
Yeah, sure. It's just a right. That
Yeah.
makes more sense.
Yeah.
Because it's only got
Am I on the right track? Or
Yeah.
even because this is a variable.
Yeah.
If I want to isolate it, then I have to take some time to make one for each one.
How come you have a plus here? I think you made a mistake.
Because the minus is here, minus one.
No, you shouldn't be a plus. I think it's a mistake.
It's
It's minus here, minus here. When you take it out,
it's a plus. Okay, so this one is the right.
minus. Yeah, you're on the right track. So try. The question is, you need to show something like this. So you need to divide the
For everything back.
yeah,
Okay.
everything by sigma 0 square.
Okay.
So then you'll be okay. Okay. Try to take this to the right side. Take these two dimensions and then divide by this part. You should be I think you're on the right track. Alright guys, let me show you how to. Right, the first thing you need to do is to, as before, like I did for question 1, try to determine the rejection rule. All right, so you will say that by the NP lemma, right, we reject the null hypothesis if the likelihood at sigma 0 divided by the likelihood at sigma 1 is less than a constant, say C. Okay. Now we have a random sample from a normal distribution with these parameters. So the likelihood is the product of the density of the normal, which is less than a constant C. Now I'm going to simplify the product of likelihoods now. So if you simplify these guys, you will get this in the numerator, and in the denominator you will get this. Okay. Now obviously you can cancel this term with this term. All right. So now if you simplify this, guys, you will get half of less than sigma 0 power n sigma 1 power n times a constant, right? You see how I got this, right? Yeah. Now, one thing I must say is that in question 2 in the test yesterday, I know maybe all of you guys did okay, but I don't know, but quite a few people had difficulty simplifying the likelihood function. That was part 1 of question 2, and I think that was due to the algebraic difficulties. I don't know what I think I mentioned this several times in the lectures. You may remember. It's really important that you know how to simplify likelihoods correctly, because if you get that step wrong, then everything else will all the remaining parts will be wrong too. Yeah, so I saw quite a few cases when I was marking yesterday the test. There were quite a few cases where the students were unable to simplify, or they had simplified to things which are simply not correct. And that's why you should go to the website, guys. You will see that I have put a link to the elementary mathematics mathematical identities that you can use to simplify things correctly. So please, I don't know, I think all of you guys probably did okay, but others who did not do okay, I think they should refer to the website for the mathematical identities to get things correct. Anyway, all right, let's return to this now. Now, the next step I'm going to do is take the logs. So if I take the log both sides, you will get This is what you will get. You should take the log. And the next step, I'm going to divide the two sides by this factor here. Now, before you divide an inequality, you must make sure the sign of this. Now, this factor here is less than 0. Can you see why? This factor is less than 0 because sigma 0 is less than sigma 1, right? So this factor is a negative number. So when you divide by a negative number, guys, you need to change the inequality around, right? So it becomes all right. This is what you get, okay? And the final step is, in order to match up with the answer, because the answer that we are looking for is the following: is we need to have a sigma 0 squared in the denominator, right? So I'm dividing by sigma 0 squared, so it becomes this times log of this. All right, guys. So this, what I have written down, is the rule for rejecting the null hypothesis under the Neiman-Pearson lemma. So now, for the sake of notation, I'm going to call this guy some of the letters. Say let's call this K, right? So this is the rule for rejecting the null hypothesis. So that completes part 1 of question 2. Now part 2 of question 2 is asking you to find the value for K, right? And once again, you are given the value for alpha. Alpha, remember, is the type 1 error, the probability of type 1 error. And this is the probability that you reject H0, which is, in this case, is the sum of right. This is the rule for rejecting null hypothesis when sigma equal to sigma 0 is equal to 0.05. Now let me ask you something. I know you guys been revising for the test a lot, but let me ask you, given that sigma equal to sigma 0, what distribution do you think this will have? This is in the lecture notes, the answer to this question. Yes, exactly, guys. If you look at equation 75 in the lecture notes, you will see that this guy has the chi-square distribution with n degree of freedom, right? So the probability that a chi-squared variable is greater than a k is 0.05. So therefore, k must be the percentile of chi-squared n with the probability of this exceeding it, right? Remember, this is how I define percentiles in mine. I know this definition is different from other lecturers. Maybe I don't know what other people are using to denote percentiles, but this is the notation I've been using. That when I say this, I mean the following. That is, suppose this is the suppose this is the density of chi squared n, all right, then this point here refers to a point along the x-axis such that the area to the right hand side, that is this area, yeah, is 5% of the total area. So this point here is equal to this, yeah. Okay. So I always in my lecture notes I have used percentiles to correspond to the right tail or to the right hand side. Okay. Okay. All right, and so that completes part 2 of question 2. Now finally, part 3. Are you guys okay with this? Or? Yeah? You're right? All right. Part 3 of question 2 is asking you to, this is part 3, is asking you to find the value for beta. Remember, beta is the notation I have used to denote the probability of type 2 error, right, which is defined as the probability that you accept H0 when H1 is true, right? So this is the probability that is less than or equal to k, which is chi squared n 0.05. Okay. Yeah. Now, to work out this probability, you must realize that we are conditioning on the fact that the true value for sigma is equal to sigma 1, whereas the value that we are dividing by here is sigma 0 squared, which is not the true value of sigma. So what you should do, I think I've done this before the Easter break, you may remember I did examples like this, right? So the first thing you must do is the following. You must replace this guy here, right, by the true value of sigma, which is sigma 1 squared, right? So because of that, I need to multiply by the same and keep this. You see in a minute why I'm doing this, because, right? Okay, now I'm going to take this factor here to the right hand side. So this becomes this. Now, once again, the same argument. Given that the true value for sigma is equal to sigma 1, this guy here must have the chi-square distribution with n degree of freedom, right? So the argument I'm using here is exactly the same based on equation 75 in the lecture notes, right? This must have the chi-square distribution with n degree of freedom. All right. So that completes part 3. All right. If you want, you can put in the sub in the values for n and the sub in the value for this one, and work out what this probability is, right? But if you leave it like this, also is fine. Yeah. Now, just a couple of announcements before you guys leave. One is that the syllabus for this course has been completed. I think you know that already anyway. So the next 2 weeks will be revision weeks for the final exam. As you know, the final exam is on the 23rd of May, which is a Tuesday. So the next 2 weeks, I will do all the lectures and all the example classes for the next 2 weeks will be revision classes. So please try to bring as many questions as possible. based on the past exam papers or the past in-class test or the lecture notes or anything. Yeah, try to bring as many questions as you can for the next 2 weeks. And one other thing is about the unit evaluations. I looked at it this morning, and it's still less than 50% have. It's still less than 50% of the course has of the students have completed. So so it's been open for a week now, and I would appreciate if you. I know most of you have completed. I would appreciate you if you could tell your friends. You could tell your friends also to complete the unit evaluations questionnaire. I send so many emails, but it seems people don't want to complete it. Maybe they are busy with some other courses. Do you have assignments or anything from other courses? Or?
I think there's a course at least one module, but I'm not too sure.
Yeah. Anyway, I tried to contact the rep for this course, the student rep, but he wouldn't respond to my email. I don't know, who's the rep for this course? I don't know.
No idea.
No idea. Yeah. No. Anyway, I would appreciate if you could tell your friends if they haven't completed it, please ask them to complete the UQ. I really appreciate that. Okay, thank you. So I'll see you guys next week, and can you, your in-class test staff here over here, please come forward and collect your.
I hate it. It's on a Wednesday.
just thought I'd
written
get
down
some
in
found these in the same ones.
I'm absolutely fine. I'm happy there. You want to show
Like
me?
velcro on my feet when I walk around.
Yeah, it takes a while to get used to issues.
But this is
When I first started wearing these shoes
Is it and here or one?
I'm used to like skating together.
Yeah, I know, it's not clear because it should be minus n, not minus 1. See, we have it as minus 1, which is not the correct answer. Yeah, that's what.
Yeah, it's just as
Yeah, you should put brackets around. Yeah, you should put brackets around. Yeah.
I think that was clear as per clear.
Yeah,
So
yeah, I know, but this is not. This is the first
So
part,
if
right?
I put it should be right.
Yeah. This is the first part. Yeah. And then you will okay. You got 8 mark, right? Yeah. So you lost 1 mark there, and then.
And the varnish, I remember the wrong varnish.
This is not right. Yeah.
Yes.
You lost 1 mark with this. So you can change it on. Right. Sweet. See, right. Where am I? Enough of the notice, right? Wait. 20 seconds. I need to have the scan, Steve. Is the photocopy, is it open now? Oh, shit. Can you guys bring this, please? Give me this. Thank you, Joe. You need to exercise, you know. You need to like go to the gym. It's going to come. Finish first.